Hello. So today we're going to be talking about a very important form of a quadratic equation that we call the vertex form. So we're going to talk about the characteristics of the vertex form and why we find it useful. So let's start by looking at a graph of the parabola y equals x squared. And what we're going to do is we're going to compare y equals x squared to the parabola y equals x squared plus 2. And here we see the two graphs here. Now, y equals x squared is this red graph here, the dotted line, the dotted curve, and then y equals x squared plus 2 is the blue graph. And we can see that y equals x squared plus 2 is y equals x squared, but it's shifted up 2 units. So what happens if we have y equals x squared minus 2? Well, let's see. That graph is y equals x squared shifted down 2 units. Well, what happens if we have y equals the quantity x minus 2 squared? Well, if we see here, this is y equals x squared, but it's shifted 2 units to the right. So y equals x, the quantity x minus 2 squared, if we graph it, is actually y equals x squared shifted 2 units to the right. So it kind of behaves in the opposite of what we would expect it to. Well, what does y equals the quantity x plus 2 squared look like? Well, that is actually y equals x squared shifted 2 units to the left. So I invite you to take a minute, pause the video, and look at these 4 graphs and look at the descriptions of them and familiarize yourself with how these, what we call transformations, work. These are transformations because they take each point in the coordinate plane and they move it somewhere else. Well, what happens if we take a parabola like y equals x squared and we change the coefficient in front of the x squared? So this is y equals 2x squared. Well, it has the same vertex as y equals x squared. The vertex is that maximum or minimum point on the parabola that goes through the axis of symmetry here, but it seems to be a bit more like that. That's the blue graph. That, I guess we could call that compressed. Well, what happens if we had y equals 1/2 x squared? Well, it looks like that. It's y equals x squared, but it's widened. Now, this is y equals negative 2x squared. So it looks like y equals 2x squared, but it is reflected over the x-axis. So instead of opening upwards, it opens downwards. And then similarly, y equals negative 1/2 x squared is the same as 1/2 x squared, so it's wider than y equals x squared, but again, it is also reflected over the x-axis. So instead of opening upwards, it opens downwards. Now you can see that in these 4 cases, the vertex of the parabola is unchanged. They're all still at the origin. But in the previous 4 graphs, when we were talking about these 4 graphs here, you see that the vertex shifted up here, down here, to the left. Sorry, to the right, and then to the left. So the vertex of the parabola got shifted from 0, 0 to 0, 2. Here it got shifted from 0, 0 to 0, negative 2. Here it got shifted from 0, 0 to 2, 0. And then here the vertex got shifted from 0, 0 to 0, negative 2. That would be here. Now you can see here that this negative 2 corresponds to this 2 corresponds to that, this number corresponds to this, and this number corresponds to that. So there's a pattern here that when we add or subtract a number after the x squared expression, that shift the parabola up or down when we write it in this form. If we take the variable x and we add or subtract the numbers directly to the x, but within the square, that shifts the parabola left or right, and that also helps give us the coordinates of the vertex. So we can actually summarize all of these by saying the following. We can summarize this by saying that the vertex form of a parabola is y equals a times the quantity x minus h squared plus k. And let's spell out what each of these numbers, what each of these variables does to the parabola. So starting from the parabola y equals x squared, we see that, as we saw earlier, hk, the h and the k are that's the vertex of the parabola. Y equals h, that's the equation of the axis of symmetry. So in other words, if here we have this is hk, then x equals h is the equation of the axis of symmetry. And a tells us the direction of the opening of the parabola. So if a is positive, then the parabola opens upwards. If a is negative, then the parabola opens downwards. So let's take a look at number 5. Now in number 5, we have a parabola that's written in standard form. Standard form means we have the powers of x decreasing by 1, and we don't have any repeats in the variables in the term. So we have an x squared term, we have an x term, then we have a number which is called a constant. So what we're going to do to write it in vertex form, remember that vertex form is y equals a times the quantity x minus h squared plus k. Now we write this as x minus h squared, not x plus h squared, to remind ourselves that the sign of h will flip depending in the direction that's opposite from what we expect it to do. So in other words, if we have x minus h squared, we're moving to the right. If we have x plus h squared, we're moving to the left. So let's see how this plays out when we figure this out. We're actually going to use that method called completing the square that we talked about earlier. So we're going to rewrite this as something squared, a binomial, something plus something squared. And then we might have some expression, some number that comes after that. That's the form that we're looking at for vertex form. So it'll look something like this here. So to complete the square, we're going to draw a square, and we're going to draw a 2 by 2 square, and we're going to make sure that everything that we write here adds up to x squared plus 8x plus 16. So we have the x squared that goes in the top left box here. So x times x gives us x squared. And because we're completing the square, we want the length and the width of the square to have the same measurements. So we divide the 8x into 2 equal parts, and we're going to put them in the diagonals here. So that would be 4x and 4x. Well, this is 4x, and this has to be 4 because 4 times x gives us 4x, and similarly here. And that automatically tells us what this box in the lower right is. 4 times 4 is 16. And so we don't have to worry about anything else outside of the box because this adds up to what we originally started with. So y equals x squared plus 8x plus 16 is y equals x plus 4 squared. Now the coordinates of the vertex, we could graph this on the calculator and look at the coordinates of the vertex, but we could also note that, as we said earlier, if this is the vertex form of the parabola, the vertex is hk. Well, here we see that this is the number where we get h from. Now, the vertex form is x minus h squared, so we see this is x plus 4 squared. So the coordinates, the x coordinate of the vertex is actually -4. And the reason why we can think about it like that is that we could say the following, that x plus 4 squared is really like x minus -4 squared. But minus a negative number is the same as plus a number. So in this case, we can think of this as x minus -4 squared, which means that the x coordinate of the vertex is -4. And the y coordinate is 0 because there's no term after this. And so we can think of this as x minus -4 squared plus 0. So that's where the 0 comes from. So the equation in vertex form is y equals x plus 4 squared. And the vertex is negative 4, 0. Well, let's take a look at a harder example, and let's see if we can deal with this one, because we don't always get a perfect square when we have an equation. And let's see what happens. So this is y equals x squared minus 4x plus 9. So we can draw a 2 by 2 square. And we represent x squared, x times x, minus 4x, so that's minus 2x and minus 2x, because we're going to take the negative 4x and split it in half. So this means that our dimensions here are x minus 2 and x minus 2, which automatically tells us that this lower right box is going to be positive 4. That's negative 2 times negative 2. But we needed x squared minus 4x plus 9, which means that we then have to have 5 extra outside of the box. It won't fit inside the box. Plus 4 plus 5 gives us 9. And so we actually are subtracting 9 minus positive 4, and that gives us positive 5. So this is really y equals x minus 2 squared plus 5. That's the equation in vertex form. And so the vertex we can actually read from the equation in vertex form. The vertex is going to be, remember, for y equals a times x minus h squared plus k, the vertex is hk. And so that means that the vertex here is going to be 2 positive 5. So x minus h is the x coordinate of the vertex. We don't need to make it negative. And then plus k, well, that's plus 5. And so those are the coordinates of the vertex. Now for number 10, the equation of the graph shown here, well, it's a multiple choice question, which makes it a little easier because then we can do process of elimination. We see that the parabola opens downwards. If the parabola opens downwards, that means that the value of a, the coefficient of x squared, must be negative. If the coefficient of a is positive, then it opens upwards. And so that means that we can automatically look at this and we see that the coefficient of x squared is going to be 1/2 times x, 1/2 x squared. So the coefficient will be positive 1/2. Can't be this. It means it can't be this either. So it has to be one of these two. Now we can see here that the x-intercepts of the parabola are negative 4, 0 and 1, 0. These are the x-intercepts. We see again that it opens downwards. So a is negative, less than 0. So negative 4, 0 and 1, 0, the factors that produce this are x plus 4, not minus 4, and then x plus 1, not minus, sorry, x minus 1 equals 0. So if this is positive 1, 0, the factor that produces it is x minus 1. The sign flips because when we set them equal to 0, we to get the x-intercepts, we will get x minus 1 equals 0, so x equals 1, x plus 4 equals 0, so x is negative 4. And so this is the equation of the graph so far. The 1/2 is given to us since they're all the same in all 4 choices, and it has to be negative because the parabola opens downwards.